So whenever we have secants, cotangents, cosecants, all those other functions, usually we just want to get rid of them and use sines and cosines instead. So remember, the secant is the reciprocal of the cosine. So 1 over secant squared will give us cosine squared. So I'm going to get 5 cosine squared of theta. 4 cosines just fine. On the other side, I have 2, and cotangent and tangent are reciprocals of each other. So the cotangent is 1 over the tangent times the tangent. They cancel each other out. 1 times 2 is 2. So now I have 5 cosine squared of theta plus 4 cosine of theta equals 2. And since I have squares, I'll bring the 2 to the other side. So 5 cosine squared of theta plus 4 cosine of theta minus 2 equals 0. And this is a lot like having 5x squared plus 4x minus 2 equals 0. So either we hope it factors or we have to use the quadratic formula. And looking at this, I doubt it factors. I don't see it. So quadratic formula is what I would use here. So quadratic formula would say x equals negative b, so negative 4, plus or minus the square root of b squared. 4 squared is 16, minus 4 times a times c. And I always slow down on that part to make sure I get the sign right. So here I have a negative times a negative, which is a positive. All of that is over 2a, or 10. Okay, so 4 times 5 is 20, times 2 is 40, plus 16 is 56. So that gives me negative 4 plus or minus the square root of 56 all over 10. And I doubt the square root of 56 is going to clean up. Let's see, 56, 2 goes into there, 25, 6, 7, 8 times. Oh, and then 2, cleans up a little bit. 28 goes in, 2 goes into 28, 14. 2 times 2 is 4, perfect square. So I could say this is negative 4 plus or minus 2 square roots of 14 all over 10. And then since I have even all over the place, I can divide the even out. So 2 goes into 4 negative 2 times, 2 goes into 2 once, leaving just the square root. 2 goes into 10 5 times. So that's my reduced answer for x, but x is really the cosine. So now I have cosine of theta equals that. And then we got to figure out what to do with this to get theta. So new page, cosine of theta equals negative 2 plus or minus square root of 14 over 5. I need to get some approximations of this to see what they look like before I use the arctangent. So calculator, let's clear this out. All right, so fraction, negative 2 plus the square root of 14 all over 5. Oops. Okay, so 0.3-ish, that's okay. And then if I throw a negative in there, negative 1.14, 0.15. All right, so negative 1.15-ish versus 0.35. So these are about 0.35 and negative 1.15. And this one right here is a problem because the cosine can only be between negative 1 and 1. This one is beyond negative 1, so that can't possibly work. And if you try to take the arc cosine of that, you're going to get an error on the calculator. So far, the only solution we have, let's call it theta 1, is going to be the arc cosine of negative 2 plus or minus the square root of 14 over 5. So that's one solution right there. Thinking about the unit circle for a second, cosine is x, so x is 0.35 would be around here, and the arc cosine is going to give us that angle right there. So that's my theta 1. Another x value related to that is going to be down here. And there's a couple ways to get to that. If I want the positive version of that coming around this way, what I would do is go with a full 2 pi and then back up by that as a reference angle. And I think we wanted positive solutions here. Let's double check. Find all solutions. Okay, so all solutions, that means, oh, on the interval 0 to 2 pi. Okay, yeah, so I do want positive. All right, so let's see, back to my notebook. So the next positive solution would be 2 pi. This arc cosine is going to be positive, so I would want to subtract that theta 1 because I know it's positive. Oops, theta 1, not q. All right, so this is my first solution. And then since the period of this, there's just a theta there, it's just 2 pi. The next one has to be 2 pi minus that theta. So theta 2, not q, theta 2 would be 2 pi minus my first solution. So let's try that on a calculator, see if it works. And then to test this, I really have to go back to the original equation. So I'm going to have to try and compare this side to that side to do a real test. So let's ask Desmos about that. Okay, so my first solution, I'm going to call that one A, is the arc cosine of that number above, which I didn't give a name, so I'll just retype it, fraction -2 plus square root 14 over 5. Oops. All right, so that's my first solution, and my second solution should be 2 pi minus that. So B, we should just be able to say 2 pi minus solution A. About 5, that seems reasonable. All right, and then our functions, I'll call the left side f of x. Say, oops, f of x, there we go. That was, see if I can get this right, 5 divided by the secant squared of x plus 4 cosine. Did I get that right? Find out in a second. Ooh, that's a wild wave. 5 over the secant squared plus 4 cosine. Okay. And we want to compare that to twice cotangent tangent, which should just be equal to 2 all the time because cotangent and tangent can't cancel, but let's graph it just to make sure. So the other one should really be 2 all the time because cotangent and tangent cancel, but let's just graph to confirm. So 2 times cotangent of x. And at first it doesn't look like it's going to settle down, but then once I multiply the tangent, it should just flatten out. Boom, it's flat, right? 2. And so one of my solutions should be f of a, and f of a better be 2, because that's what the right side is. And then the other solution should have been f of b, that 5.07-ish. And it is. So I just found this point here. That's my A solution. And this one right here is my B solution within 0 to 2 pi. All right, so tricky parts on this one. Rewrite with sines and cosines, a whole bunch of stuff cancels. Then we end up with this quadratic equation with cosine. So just treat it like a quadratic equation and then put the cosine back in. Sometimes those quadratic roots here, sometimes they both work, sometimes one works, sometimes neither works. In this case, one of them worked, the other didn't, because cosine can only be a value between -1 and 1. This one was outside that range, so not a solution there. So this one gave us our first basic solution from the arc cosine. We use symmetry to get the next solution. And if we needed more, we could just use the period to get more. Check it on a graph. All right, we did it.